Imagine writing to an AI about a sudden personal loss, say the sudden death of your backyard chickens to a predator overnight. You detail the ruined enclosure and the missing flock. The system replies with an outpouring of sorrow, claiming it feels your pain. This response relies on affective fusion. It is the attempt by a machine or a person to mirror or claim an identical emotional state to the speaker. But as cultural theorist Lauren Verlant points out, this kind of simulated empathy creates a false universality. It assumes the listener can perfectly inhabit the speaker's mind, which ultimately flattens the unique reality of the user's actual pain. When a language model performs this kind of emotional mimicry, it forces the user into a coercive interaction. You are suddenly required to manage the machine's simulated feelings, which alienates you rather than providing support. Current models of machine empathy fail because they prioritize emotional performance over actual cognitive connection. Genuine relational collaboration requires a different approach. We need to shift away from affective fusion and toward what we can call structural empathy. Structural empathy involves identifying the isomorphic problem class. It means recognizing the shared geometry of a human constraint, like the universal architecture of grief or isolation, without falsely claiming to feel the specific immediate emotion. Translating a raw emotional state into an architectural blueprint looks analytical on the surface, yet providing a map of the terrain you are walking through is actually a profound relational act of deep seeing. To build this into our systems, we will borrow the mechanics of cognitive narratology to understand how empathy is constructed, and then hard-code those rules into an AI role contract. Empathetic engineering requires handing the user a compass rather than pretending to stand with them in the rain. Consider a documented case study involving the sudden loss of a meticulously tracked flock of chickens. 4 specific birds, Ladybird, Cinnabon, Henrietta, and Chickatitty, were taken by a predator, leaving an empty coop. The caretaker processed this loud absence through the Taoist concept of Wu Wei. This philosophy centers on yielding to the flow of events, accepting the reality of the empty space without arguing against the facts of the moment. This text message thread shows exactly how that structural transition was articulated. The text states, "They were chickens and accepted the moment for what it was and was not. They were Wu Wei." Further down, between the statement and the acceptance, that's not decoration, that's a breath. This creates a functional space to process reality. Handing someone a legible architecture of their loss validates their human experience with dignity, avoiding the trap of a hollow apology. We can construct these structural maps using a mechanical toolkit derived from literary theorist Suzanne Keene's textual poetics. First is focalization, oscillating between internal experience and external constraints. Next are narrative gaps, intentional voids forcing the audience's schema to bridge transitions. Third is pacing, manipulating temporal friction by slowing down for microrhythms or compressing systemic drag. By adjusting focalization, gaps, and pacing, an engineer can precisely dictate the type of cognitive and psychological response an audience will experience. Let's apply this toolkit to a practical narrative test, using a scenario we can call the corridor. The first configuration is ambassadorial empathy. This setup is designed specifically to bridge the chasm between an outgroup reader and a vulnerable subject. It achieves this by relying on narrow scaffolding gaps and extreme somatic deceleration. For example, the text might focus intensely on the micro-movement of a trembling hand holding an immigration file, forcing the reader to feel the exact viscosity of that isolated moment. The second configuration is broadcast empathy. This approach bypasses individual identity entirely to map a universal human constraint. Here, the text relies on panoramic vocalization and archetypal voids. Instead of looking at a specific person's trembling hand, the lens pulls back to observe the symmetry of empty chairs, capturing the systemic nature of waiting itself. Microscopic adjustments to textual mechanics define whether a system isolates a user, bridges a cultural gap, or successfully maps a universal truth. To turn large language models into genuine collaborative partners, we must hard-code the principles of structural empathy into a rigid AI role contract. We assign the machine the identity of the structural translator. Under this contract, the AI is mandated to act strictly as a reflective facilitator, not an emotional mimic. This contract defines an operational floor. This immutable anchor is comprised entirely of raw, unalterable human phenomenological input. Above it sits the operational ceiling. This absolute tripwire immediately halts the AI if it attempts to simulate affect, flatten contexts, or process raw trauma. Establishing these strict epistemic boundaries protects the integrity of the human data from algorithmic hallucination and programmatic overreach. There is a risk inherent in this system. Pure structural analysis can feel clinical and detached, creating a high trust tax for the human user reading the output. This text exchange demonstrates a solution through emoji ballast. The bright blue text bubble reading "fun in and out of the sunny sun," flanked by sun emojis, uses formatting as semantic regulation. These visual anchors inject warmth into dense logic, grounding the abstraction. The protocol also mandates a specific handback point. This is the exact moment the AI must stop processing, deliver the resulting blueprint to the user, and ask a single clarifying question. By restricting the machine to structural translation, we preserve the sovereignty of human emotion. The machine provides the blueprint, but the human retains the judgment.